Okay, in this example, I'm going to return to a function and a problem that we've seen before. So in section 2.1, when we were doing tables of numbers, we saw this problem with a falling ball, and we approximated the velocity. And then in section 2.2, I gave you the formula for the velocity, but we didn't know where it came from yet. And so now that we know the shortcut rules for derivatives, we're going to just see how they work in this case and hopefully, get the same thing that I gave you in 2.2. So let me start by reminding you that velocity, which is what they've asked us to find, is the derivative of position. So this problem didn't say find the derivative, not using that word, but that really is what it was asking. So velocity v of t equals derivative of position. And we've been given the position formula of negative 4.9 t squared plus 15.5 t plus 2. So really, what we have to do is take the time derivative. So I use that Leibniz notation d over dt, which means the derivative with respect to t of negative 4.9 t squared plus 15.5 t plus 2. And I'm sure some people can do this in one step, and I'm not going to break it out a lot, but I'm going to break it into two steps. So ignoring the plus and minuses is something that almost everybody does kind of automatically, and I won't make a big deal about that. But I will, I'll do one step where I show each part of the rules, or I guess the steps of the rules, and then I'll do a second one where I just kind of clean up my answer. So here's what I mean. I'm going to write this as negative 4.9, and I'm going to bring the 2 down in front, and then I'm going to subtract 1 from that power, so I have t to the 1. And then 15.5, I bring the 1 down in front, I subtract 1 from that power, and I have t to the 0. And then finally I will say plus 0. So that's done with the derivative, but now I will clean it up and write it the way people usually do. I'll multiply the negative 4.9 and 2, so negative 9.8 t. And usually we wouldn't bother writing times 1, right? We would just get rid of that 1, and usually we wouldn't bother writing t to the 0. After all, if we have 0 t's, don't write them. So usually we would just write this as 15.5. This is in all meters per second, so if I want to be extra careful, I should put the units in there. But that's the final answer. And that is the formula that I gave you in section 2.2. And again, you can skip the middle step if you want. If you're learning these rules for the first time, then write out an extra step or so. But if you've used them before, you can see that in the end, it's mostly multiplying by 2 and subtracting 1, and you can hide some of those details.